Hello, this is Mrs. Taylor, and I'm going to go over how to evaluate and graph step functions. And for this video, we're going to use the greatest integer function, which is the function where you determine the greatest integer that's less than whatever value you have in that function. And so for these two functions, it says evaluate each function for g of 3.4. And so with the greatest integer function, you need to remember that you plug in your x value first, complete whatever the operations are inside of the greatest integer function, then round down, then finish with whatever's outside of the function. So on the left, everything you do is inside the greatest integer function. So you would just evaluate 1/2 times whatever the x value is plus 2, and then round down. That would be your answer. For this second one, the only part that's in the greatest integer function is the x. So you would plug 3.4 into the greatest integer function, round down, then evaluate by multiplying by 2 and subtracting 7. So let's go through those steps. On the left, we're going to evaluate g of 3.4. And so the first thing I do is I replace x with 3.4. After I replace the x's, then I evaluate what is in the greatest integer function. So 1/2 times 3.4 plus 2. So that would be 1/2, which is 1 divided by 2, which is 0.5. So 0.5 times 3.4 plus 2, and we get 3.7. And then after I've evaluated what's inside of the greatest integer function, from there what I do is I round down to the greatest integer less than 3.7, which would be 3. So after evaluating g of 3.4 for our function on the left, I get a value of 3. Now on the right, we're going to do the same steps. We're going to start with replacing the x with 3.4. So once you substitute, it looks like this. And in this case, the only thing I have in the greatest integer function is 3.4. So my next step would be to go ahead and round down the 3.4 to the greatest integer less than that, which would be 3. And once you've rounded down, the greatest integer function goes away, you replace it with parentheses, and then you just evaluate. 2 times 3 minus 7. 2 times 3 would be 6, minus 7 would be -1. So in my function on the right, g of 3.4 equals -1. So after you know how to evaluate, you can move on to graphing. And when we graph the greatest integer function, we get a step function, which is called a step function because it looks like a series of steps, a case of stairs. And so what you do is you can start by creating a table, and that kind of gives you an idea of the way the function will behave graphically. And then after you've established the pattern, you can just continue that pattern up and down your graph. And so that's what we're going to do here. So the first thing we're going to do is we're going to take these x values, plug them into our function, get a y value, so we can get an idea of what our greatest integer function graph would look like. So if I plug in 0, 0 plus 4 is 4, greatest integer would be 4. If I plug in 0.5, 0.5 plus 4 is 4.5, and again I round down to 4. Plug in 1, 1 plus 4 is 5, greatest integer is 5. Plug in 1.5, 4 plus 1.5 is 5.5, round down to 5. And then last we have 2, 2 plus 4 is 6, greatest integer would be 6. And so this kind of gives me an idea of what my steps will look like. And so I'm going to start plotting some points. 0, 4, plot that one. And then 0.54, and then at 1 it jumps up to 5, and then at 1.5 we have 5 again. And it's just going to continue. And of course, when I get to 2, I have 6, that runs off the graph I have here. And so what I'm seeing here is it's starting at this endpoint on the left and it's traveling to the right. And then when it gets to the whole number, it jumps up. So the way I indicate that it's traveling all the way across until the whole number is with an open circle. And so I place an open circle here on the right. And then the last thing I do is connect my points. And now that I understand the pattern, the segments are a unit across, the closed circles on the left, open circles on the right, I can just continue that pattern for my entire graph. Start with some endpoints. For this particular graph, it's open on the right, closed on the left. And then after I get a few drawn, I connect them. And you may notice that some graphs that we do in class have 3 points across, but once you have established the pattern and you understand what the particular function should look like graphically, you don't have to have the 3 points. You can just have the 2 endpoints and be done. And so that would be how you would graph a step function.